Alright guys, welcome. It's Geometry, Lesson 5.7, the Pythagorean Theorem, and let's take a look at what we need to know. First of all, the Pythagorean Theorem states the following relationship. We've talked about it in class, you've seen it before in previous classes, but what we're looking at is in terms of our sides of our triangle, the relationship that they have, A and B, the shorter sides compared to the hypotenuse. And we're looking at the two smaller sides. A squared plus B squared are always going to equal C squared in any right triangle. Okay, so those legs A and B are going to be important in terms of its relationship to the hypotenuse, which is the longest side, or C squared, the side that's opposite of your right angle. So as you've seen before and things we've talked about in class, how the Pythagorean theorem came about, we're going to see some things that we're going to use it for here in class in geometry. So, in order to calculate the Pythagorean theorem, in an example like this, one of the things you're going to have to do is know how to apply the theorem. So we have a leg of, or side of 6, so the other leg side is x, and then we have the hypotenuse side is 9. So when we set this up, the very first thing we want to do is write the Pythagorean theorem out. A squared plus b squared equals c squared. Then we're going to substitute our numbers in. So you can see that we took the number 6 and substituted it in for one of the sides. We took the number 9 and substituted it in for c, which was our hypotenuse. And then we went ahead and changed that to x squared to give us a variable to solve for. So after we've plugged it in, we're going to go ahead and simplify or take the squares. So 6 squared becomes 36. 9 squared becomes 81. You can see that. We just went ahead and simplified it right there and simplified this right here. And now we have an equation that we can solve. Go ahead and subtract 36 from each side. So when we do that, we want to take 36 from here to get x squared by itself and take 36 from this side. 81 minus 36 gives us 45. Now we have to solve for x. So we find the square root of x, we find the square root of 45, and we get x equals the square root of 45. And then we want to simplify by understanding that we got 9 times 5 is what 45 makes up. So the square root of 9 times the square root of 5. Square root of 9 becomes 3. And then we keep square root of 5 the same. Can't be simplified any further. So that would be our solution. So x, or this side, would have to be 3 square root of 5. Take a look at another one. In this case, they give us x as one of the sides, 4 as a side, and x plus 2 is the hypotenuse. So we're setting up a problem. We want to go ahead and find the value of x. And so, again, we're going to write the Pythagorean theorem. A squared plus b squared equals c squared. We know that this is our a squared, or our a, this is our b, and this is going to be our c. So x squared plus 4 squared is going to equal x plus 2, that quantity squared. We're going to simplify what we have. So x squared plus 16. X plus 2, what we're going to do here is go ahead and take x plus 2 and multiply it by x plus 2. So x times x is x squared. X times 2 is 2x. 2 times x is 2x. So there's where we get our 4x's. We add those together. And then 2 times 2 equals 4. Now we're going to combine our like terms, and what we see is when we subtract x squared from x squared, they cancel each other out. 4x we can get on one side, and you minus 4, and 16 minus 4 gives us 12. So all we've done is simplify and combine our like terms. Solve for x, divide both sides by 4, and we get x equals 3. So we can identify that x equals 3. So this would be 3 4 that we know, and then 3 plus 2 would give us 5. So it's a 3, 4, 5 in terms of the sides. And that's the first part, is being able to go ahead and solve or find the missing sides. So on your sheet of paper, go ahead and pause the video and try to solve these 4 problems. When you're done, you can restart the video. Okay, now that you've solved those 4 problems, we're going to get to the second half of the video, and we're going to talk about the Pythagorean triple. The Pythagorean triple is a set of 3 non-zero whole numbers that satisfy the equation. That's the important part. They have to satisfy this equation, a squared plus b squared equals c squared. So when you plug these numbers in, it's going to make this true. If I took 3 squared and I added it to 4 squared, I'm going to get the exact value, which is 5 squared. So this is 9 plus 16, which equals 25. And if I went ahead and 25 equals 25, so yes, it's true. Okay, that is what makes it a Pythagorean triple. If you look at 2, 3, and 4, if I took 2 plus 3 plus 4 and squared each one, 2 plus 3 equals, let me go back and just erase that. If I took 2 squared plus 3 squared and made it equal to 4 squared, what we're going to see is we have 4 plus 9 equals 16. 13 does not equal 16. So it's not a Pythagorean triple. So a quick way to test it out is to go ahead and plug the numbers in and test to see if it's true. When that comes in the case is when we're going to use that to classify, and some of those strategies to classify what type of triangle we have. This is extremely important. These are things that you're going to see in your quiz. You can always follow the theorem to classify the triangles, okay, by their angle measures. So as we've talked about so far this year, if you know their side lengths, you can use the length for the longest side for C. So in this case, what we're saying, the inequalities theorem, the Pythagorean inequalities theorem lets us know that if I took angle C and I can identify it as being greater than 90, which makes it obtuse, okay, it's greater than 90, or it's going to be acute because the measure of angle C is less than 90. We're looking at that in terms of the sides. So here's an example. They're giving us measures for 3 of the sides to be 2, 5, and 6. Okay? We've talked about earlier in this chapter that we know this can be a triangle because we take 2 of the sides and add them together. It's got to be larger than the third side. So 2 plus 5 is greater than 6, which is true. 2 plus 6 is greater than 5, which makes that true. And 5 plus 6 is greater than 2. So we know that these 3 sides can make a triangle. That's our first step. And then what we have to do is go ahead and plug our values in to the Pythagorean theorem to see if it makes what it does or what it identifies. So in this case, we're going to take the 2 smaller sides as our legs and the larger side and make that the hypotenuse. So 2 squared plus 5 squared, and then we don't know what it's going to equal. So as you see, they put a little question mark, and then 6 squared. So 2 squared is going to be 4 plus 5 squared, which is 25, which equals 29. 6 squared is going to be 36. So 36 is greater than 29. So since c squared is greater than 29, it's obtuse. Whenever the angle is, the hypotenuse is larger than the other 2 sides, then we know we're going to have an obtuse. That's what we're seeing here. When c squared is greater than the other 2 sides, it's going to be an obtuse angle. Okay? If c squared turned out to be less than the other 2 sides, then it's going to be an acute angle. So using that, we can plug in values for the sides to find out what type, or classify what type of triangle we have. Go ahead and try that here With numbers 7 through 12, they're going to ask you to classify whether you have an acute, obtuse, or right triangle. We know that it's going to be right if we have it all equal to each other. And here they want you to find the missing side length, using what we talked about with go ahead and solving for our missing side. When you're done, you may move on to the next step, which has been identified in the email I sent you.